så optager vi. Velkommen til. Det, som vi har sagt, der flere, som allerede her er installeret. Så jeg springer over en stor del af den her installeringsproces. Men det er her en reference af dem, som har ikke er installeret, kan bare prøve at gøre det. Og vi har en kaffepause, og forhåbentlig I kan catch up med os senere. Okay, så fint. So where do I, where do I find it? Download, fint, on your computer, install, resultatet, efter installering. Så selvfølgelig en tekstbaseret user interface. Der er en graphic user interface, som kaldt Studio. Jeg holder væk fra graphic interface, fordi jeg ikke sikker på, at alle de funktioner, alle de installeringspack, som vi vil gerne bruge, ligger på den grafisk interface. Så jeg holder væk fra grafisk interface indtil videre. Så vi skal fortsætte med skriftlig, med en tekstbaseret interface, som jeg er klar over er frustrerende og labor intensive, som er ikke sjov. Jeg kan ikke selv lide en tekst interface, men det er nogle ting, som vi skal overstå, når vi har brug for meget høj teknologi her. Så vi skal starte med den her data. Så hvis du vil, jeg tror vi allerede har sidste gang brugt den her data, men dem som måske var ikke til stede sidste gang, du kan finde den her datafile på D2Learn. Det er Minnesota Highway data. Så vi skal starte med den her data, og den til bruge den her data, jeg stærkt anbefaler, at du laver en malnem map adress, fordi den er tekstbaseret, og det bliver kedeligt malhurtigt, hvis man skal indtaste en lang adresse hver gang. Så jeg stærkt anbefaler, at du laver en kort map adress lige på harddrev C, som er nem at nå. Og det er meget bedre i forhold til tekstbaseret adresse. Og vi har brug for, man kan bare bruge tekst data, man kan bare bruge comma separated eller tab separated data. Men vi har så mange ting, som ligger i Excel, så det er brug for, at vi har Excel adgang her til R. Så vi har brug for en pack, en Excel pack, Excel SX pack. Kan du følge med, at hvis du bare kommer i gang nu, tænd og install den her Excel pack, som jeg viser her på skærmen. Er du klar? Er jeg klar? Kan jeg komme videre, eller skal jeg pause lidt her? Jeg pauser indtil flere jeg siger, ja, jeg har installeret den her pack. Lykkes det? Okay, jeg har en. Ja, done. Okay. Jeg har nogle få svar her. Done. Okay, tak Abdul. Jeg vil få lidt mere flere svar, indtil jeg kommer videre. Jeg har 3, som har godkendt, at det, som har klaret den her installering. 4, så Rasmus har det. Lina har det. Okay, og Tobias. Okay, så jeg kører videre her. Okay. Og så du har installeret det, men det er ikke aktiv endnu. Så nu man skal indlæse pack, så det bliver aktiveret. Så vælge her indlæse pack, og igen indlæse XLSX. Og så er det endelig klar til brug. Og den man kan tjekke, man kan control, at det er faktisk den her pack installeret. Så hvis man kigger her på venstre, den command library parentheses. Hvis man indtaster library parentheses, der kommer op den her vindue, som viser, okay, hvilke pakker har du installeret? Og den, man kan control, at det er faktisk Excel pack installeret.
Steven?
Yes.
Jeg får en fejl, når jeg loader den. Så der package og namespace load failed for XLSX. Og jeg fik downloadet den.
Package og namespace.
Ja, jeg kan jo lige...
Kan du indtaste det i chat?
Ja, det var det, jeg skulle til.
Okay, jeg kigger på det.
Ja, der er også mere end det, men altså, der står, at jeg fik downloadet den succes, altså, hvis jeg bare skulle installere det. Men det er, når jeg skal load den ind nu.
Jeg har samme problem, Tobias. Mit virker heller ikke.
Så når jeg finder nogle filer, som den her løsning er, at jeg bruger min ven Google. Så jeg prøver det her. Okay. Okay. Package or namespace. Namespace. Okay. Load failed for SLX. Let's take a look here. Come on. Here we go. So, all right, what is the issue here? I was doing this and this happened. That's not very helpful. Alternatives. They're recommending an alternative package. Okay, so prøv den her alternativ, den her pack som er kaldt Open XLSX. Og der er kun en udfordring her, at alle mine slides bruger command fra XLSX pack. Jeg ved ikke, hvis det er det samme eller forskellige. Jeg ved ikke. Så open XLSX reference manual. All right. So det desværre er I lidt på egen vej her. Open 47. 47? How many pages does it take to 47? Yeah, so yeah, open Excel file. Okay. Yeah, så hvis du bare hurtigt Google, ja, tak for det. Tak for det, Maho. Så desværre, jeg kan pause lidt her, når du sætte den her ind i jeres installering. Jeg har ikke oplevet nogen fejl, men pack Excel XX på min computer, så jeg bare gør det på den måde. Men desværre, det kan ske, at forskellige software-installeringer og forskellige operating system, ja, desværre. Så det er hvorfor jeg afsat den her til præsentation. Fordi jeg var sikker på, at der vil komme noget udfordring. Der vil komme noget teknisk fejl. Så det er, som det er. Så jeg kom lidt videre her, og den vi har kaffepauser, og I kan aflyse den her. Så bare en få lidt mere skridt her, og den, wrong picture, there we go. Yes. So read, læs filen. Så med min pack er det som her, det er my data. Så my data er bare min egen navn. Det kan være din data, det kan være new data, det kan være data 1, data 2, det er bare en navn. Så bare sæt en navn, som du vil bruge til at indholde data i R's hukommelse. Så jeg har valgt my data. My data, og den lige som jeg har tastet her, my data, og den less than stry read.xlsx, parenthesis, field path, og den jeg kan ikke huske faktisk, hvad den nummer 1 mener, men jeg kan ikke huske faktisk, jeg bare gør det. Og den her command, ls parenthesis, ls er list. Så ls er en command, som man taster list, og den der vil vise alle de ting, som ligger i R's workspace, i R's hukommelse, eller ikke hukommelse, because når du quit og den åbner igen, det vil gemme alle de ting, som ligger ind i workspace. Så det er ikke hukommelse, det er en fast workspace, som er faktisk gemt på disk. Som man vil finde ud, som jeg fandt ud i morges, når jeg vil forberede mig til præsentation i dag. Jeg åbner og jeg kaldte ls, og det var alle disse her ting, som jeg har lavet for 4 dage siden. Men i hvert fald, så ls, så det viser, okay, ja, det er den her, hvor er min mus? Det er den her, jeg skal faktisk, kom nu, come on, annotate, yes, so, read the data in, ls, show me what's in the system, this is what's in the system. And I'm switching to English here, guys. And then just typing my data alone without anything else, all by itself, and wham, all the data just pops up on the screen like this. And that's not so bad. That's not so bad. So, and then prøv her at tegne en almindelig scatterplot. So they're også nem. It's also easier. There's this function called attach, and when you attach the data, it means that you can refer to the data without having to type in all of the label, all of the information about the data. You can just go straight to using the names from that data. So attach and then plot, and then you can just type in the columns from the data without any other explanation, and it will just do it. And then I found later, after some experiments, that this part right here is actually optional. That is, if I don't do this, these labels on here still came out the same. This is probably if I want a label different than the name and the data set in the column. I just want to make up something, whatever. So what is the clock here? I heard the bell ringing in the living room. Yes, kaffepause. Så vi tager en pause her, og da vi kommer tilbage, og vi kan ret hurtigt komme med noget interessant resultater her for med den her. Så vi tager en kaffepause, og også lidt længere, fordi dem, som måske har brug for til at få styr over XLSX packs, eller OpenXLSX packs, eller installere så vi tager 10 minutter her, og jeg skal finde frem til timer. 10 minutter. Yes. Time has started. Kaffepause. Vi ses. Wake up. Alrighty. All right. So, yeah, so here's my window. I'm going to scoot my window in here. And there we go. There we go. That'll just fit. Come on. Yeah, just right there. So Control L clears the screen. So there are my elements. That's all I got right now. And here's the data. All of this stuff here, I don't know why it does it. All of this is all empty columns. All of this NA is empty columns. I don't know why it's importing these extra columns. I could read the documentation and find out, but I'm too lazy. I don't want to. But for some reason, it reads in extra columns that are just empty, which is kind of annoying because, you know, maybe the other pack doesn't do that. Maybe you guys will find out the other pack is better. I use this pack because it was the first one I found and it worked for me. So why change? That's the way stuff is sometimes. So until it breaks, until I find out it doesn't work, I'll just keep using it. But here's the core data. Here's our data right here. And here are the column names. And another thing I found, and we'll see later in the presentation, is, man, it is not fun. It is not fun to try to rearrange columns, rename columns, reformat the data inside R. It's not fun. So it may be, for some of you, maybe even me, it may be easier to rearrange the data in Excel and then re-import it to get it into R in a different format. That's probably what I would actually do if I weren't teaching you this class right now. I mean, I personally would probably just do it in Excel, but there might be occasionally a reason why you cannot do that. And so it's good to learn how to do it without Excel, just in case. So that's what we've got coming later in the lesson. So anyway, so there's the data, and let's clean the screen again. And then, so just plot, and I'm just gonna plot, I don't think you saw this, but I've already attached it. I can just attach again, just to make sure. And it's gonna tell me, you dummy, you already did this, I think is what this error message is telling me. So let's skip that. And it's case sensitive. This is so annoying. It's case sensitive. That I hate. I really hate that. I wish there was a way to turn that off. Any of you bright people out there know a way to turn off, but I guess you can't. I guess that would be a bad idea. And actually, I could just stop right here. Oh, come on. Oh, I misspelled it, dummy. And I got to turn the case sensitivity off. There we go. Do it one more time. County, C-N-T-Y-P-O-P-A-A-T. And bang, there it is. But you could do some other, like I did in the example on the presentation. Whoops, P-L-O-T. Whoop, come on, nope. And what did I do? Remind myself. It is main. This is the kind of stuff you forget. Main equals. That's it. Main equals. Even I need a little cheat sheet to remember where everything goes. Comma. Whoops. Comma. A-T. Comma. Main equals. Look at my plot. And X label, and I will make sure I think I've got that right. I hate text-based interface. X label, this is the X label. And Y label, why not? And that should work. There you go. And so anyway, we got that. Good enough. There's our data. And right away, looking at this data, we had this conversation last time, but I'll just refresh this. Right away, we see a couple of things. We see a problem with discrete levels in the data that are hard to manage. We have these discrete levels. Let me refresh this conversation for those of you who weren't there. We have a discrete level here. There's this jump. It's not really a smooth, real value data, and this is kind of a problem. And we have a growing variance as the data moves forward, and this is also a problem. So this is kind of the stuff that makes the regression less accurate or less useful, but we will get into that. So let's see, next on the list here, what's next? All right, I already demonstrated that. Oh, I did not demonstrate this. I did not demonstrate this. So quickly, let's take a peek here. There's everything in there. What if I want to delete something, right? Remove. And it's gone, right? It's gone. So now I got to get it back in again. Read X, L, S, X, C, oops, C, come on. Highway, data, X, L, S, X, 1. And it's it, and I'm back. And there it is, and we're back. Okay, so next, okay, yeah, let's do the basic here. And I will wait a moment because, so this command right here, go ahead and do it right here. Do this right there. Do that. Oh, some of you are going to have a problem. I'm waiting to hear some of you say you can't do it. I'm waiting any minute now. Yeah, Rasmus, are you having fun yet? Isn't it great? Don't you love? You must hate it, right? Don't you love living in a world where everything's American centric? Don't you love it, right? I mean, here's this critical, important piece of software that we're all supposed to use. And of course, it's made by an American, and it assumes that everything is easy to get to like an American's computer. So this damn tilde key is I can't say it on screen. It's not family friendly. This is a problem. And you can Google it and pick a solution that is good for you. I did not like the first few solutions. And I'll tell you what my solution was. I just finally gave up and switched to an American keyboard because all the other solutions didn't work. There's all these different solutions about, you type in the ASCII code and crazy stuff. Didn't work for me because there was something weird. It worked if I had Microsoft Word open. I could open Microsoft Word and I could type it in Microsoft Word, and then I'd open the R and I could not type it in R. I was like, come on. So yeah, you copy to the clipboard, and that'll last about 10 seconds before you want to throw your computer in the wall and walk away. But for me, the solution is I have the US keyboard template installed on my computer, and I just toggle the keys on my computer. When I get to this step, I switch to the US keyboard. And I have As an American, I have the US keyboard memorized, so I know where this is on the keyboard. Maybe for you, print out a picture of an American keyboard and then switch to American keyboard and type it in, and then switch back to Danish when you're finished doing this part. But this is so annoying. It is absolutely infuriating that this function is completely dependent on this one character, this one keystroke. You cannot do it without this keystroke, and it is nearly impossible to get access to on a Danish keyboard. So, but all of you, find the solution that works for you. American keyboard, ASCII code, copy it and paste it to the clipboard, have a Microsoft Word document over in the corner with this character on the screen, and copy and paste it from there into R. I don't know. I'm sorry. I wish I had a better solution, but there isn't. And I Googled this and I looked for, what are people saying? And I Googled in Danish and I found Danish websites with complaining about this. Sorry, there's no easy fix here. Anyway, I've talked here while I hope you're solving this problem. Here's, as I said, American keyboard. Here's the American keyboard picture right here. You can print this out if you want. There's American keyboard. And on an American keyboard, it's just Shift, upper left key on the keyboard. So I've talked about this for a few minutes. Hopefully, while I've been talking, each one of you has solved this and figured out what you're going to do, and has also tried running this function in R. And so I think I've talked about it and waited long enough here. So I will go to the next screen. And here's your result. Here's your result for that command in R. And the blue on the upper right, this is R. This is, come on. This is R right here. And this is the same thing we did last week. It was last week, wasn't it? Yeah, it was last week. No, it was the week before. It was 2 weeks ago. 2 weeks ago, we did this with Excel, and this is the result in Excel for the same data set, for the same variables right here. We did that. So you can compare those two and see where the answers are and how things are presented and stuff like that. A little annoying, but it's not new. It's not new. Did you notice this? Take a look at this, guys. R says this is the multiple R square right here. See that? Microsoft Excel says this is the multiple R square. That's not very helpful, is it? That they don't use the same label, because you can clearly see the correct, the matching value is down here. And stuff happens, and it's annoying that when software doesn't agree, right? So this multiple R square is the quote, the standard R square that people refer to. So the standard R square, the R square that whenever somebody asks you what's the R square, this is the one they're looking for right here, this one. The others are, I don't want to go into it. The others are extra. They're extra. They're for other purposes. But this is the standard. This one right here, this one and this one. These are the standards that everybody's looking for most of the time. And then we have our p-value for the regression down here. And we have our p-value for the variable right here, et cetera, et cetera. Good. So we got that. And these other numbers down here that we got quickly with Excel, these you have to use a separate command to show them automatically in R. And we will see that. I believe I have that on the next slide. I do have it on the next slide, actually. It's on the next slide. Here we go. Let's take a look. It is on this slide. This is the command you need to run to get the extras, the confidence levels. That's right here. So this, you need to run an extra command to get it. And this is kind of not really super useful because this information was already presented on that previous screen. And then the residuals, this command actually prints out, actually generates the numerical residuals all by itself, which is not as useful as the next thing I'm going to show you here. So here's our plot. If you just, now, let me explain what, just in case everybody's unclear, plot fit. So this is a shortcut. This is a smutvi here. This is a shortcut. Let me go back just to make sure everybody understands what I'm looking at. Fit is the name of this regression result. And right here, I remember I called this fit. Whoops, come on. So this is the name. This is the name of the result in memory. So it has actually saved, it has calculated the regression, and then it has put it in memory and saved it. So I can now call it back and refer to it in calculations later. So fit is the name of, I gave that name to it. I gave it that name. So fit, so then I call fit to get the results. I call fit to get more results. And then if I just go plot fit, it will automatically just generate some standard expected plots. So for example, it will generate this residual plot. Now this residual plot is a little different than the standard plot from Excel. The Excel residual plot is a plot against the X values. But this residual plot is against the fitted values, the Y hats. It's almost the same. The picture is nearly always the same, but just be aware that it is a small difference there. Small difference, but not a huge difference, but a little bit of a difference. So to see this on my screen, so to do this, I'm going to back up here so I remember what I'm doing. Yes. So there we go, my data. Yes, I have the data, clear the screen. So fit and US keyboard, here we come. And no, not yet. Come on, give me a hard time. Let me get this right. Yes, there we go. There we go. Thank you, Mr. US Keyboard. All right. So annoying, these too many screens. All right, here we go. Fit linear model. Now I got to remember where this is driving me nuts. All right, ADT, this, and lanes. Yes, that looks correct. Yes, summary. And I got that. Yes, and so now plot it. And it brings up this window. And now I actually have to hit return. It's going to scroll through a couple of different plots. And there's probably a command that I can pick to choose which different sets of plots I get. I just didn't bother to look up the details. But here's the first. Here's our residual plot. And then here's our normal probability plot. And this is something we will talk about some more later. What this plot does is it is giving us some knowledge. It is giving us some information about whether or not the residuals are normal distributed. Remember that in linear regression, normal distribution of the residuals is one of our expectations. It is one of the things that we believe is going to happen. And so it's important to check this plot because if the residuals are very far away from normal, we got a problem. Now in this plot, we have some movement away from normal. This is a little bit ugly up here. This isn't so bad. This is pretty good. A little bump here, don't know what's going on, some kind of crazy bump here. Then we come back to pretty good. So we got a mix here. It's not the end of the world. It's not great, but it's survivable. I mean, in real world data, you're not going to get this nice and clean all the way up this line. This dotted line here is what we want to be aligned with. We want this dotted line, all of our residuals to be on this dotted line. It's not going to happen, but it would be nice, but it's not going to happen. So there's a judgment. A lot of what we do here in regression is going to be judgment. It's going to be subjective. And yes, you're going to complain to me and say, I answered this on the exam and you told me it's wrong and I think it's right. Yeah, that's going to happen. That's going to happen because it's not a precise science. It's not. I don't care. It's not. I'm telling you right now, it's not. I just spent last week, for example, checking through our textbook and comparing it to my textbook from when I was a student. And I already find that these two books don't agree with each other. I like mine better, but we'll stick with the designated book for now. They don't agree with each other in some places. And that's because there are places where scientists and researchers do not agree with each other in when things get complicated. And that happens in regression. We have data that's coming from the real world. It has flaky, funky stuff in it. It is dirty data. It is dirty data. And then we throw it into this mathematical model and results come out, and sometimes there's an argument about, which part of bad do we accept, right? Where do we compromise? So we will see that. We will see that. And in the papers that I gave you to read, there's that same problem. It's not so easy to just push on the button and say, give me the answer. There are compromises and there are questions, and you have to look at the data and the results and say, oh, okay, this is the choice we're going to make. This is the choice we're going to make. And somebody else might take a different choice because they are willing to accept different failures. It's a matter of what are you willing to accept as a failure. You can't have it all. So where are you willing to take? Where are you willing to let go? Where are you willing to accept less than perfect results? So anyway, let's go to the next step here. Let me get my mouse back. Let me get this back. And that was that. Oh, I just sprung over. Come on. All right, let me go back. We'll do it one more time. Plot. One more time. Here we go. So that one, that one, that one. So this is kind of like a residual plot. I don't use it that much, really, but it's another way to show emphasis on how the residuals are changing as a function of the location on the output on the fitted line. Now I don't use it that much, but it's there. I have not ever actually done anything with leverage. That leverage is a technical term for an analysis statistic. And to be honest, I have not done a lot with it. And it's maybe we'll look at it. I don't know. We may not have time. There's so much we could do. We could spend enormous amounts of time on regression, and there's just not going to be that time. There's all kinds of stuff in your book and in other textbooks on regression that we will not have enough time to cover. So we won't get to it all. But there are lots and lots of different statistical things you can do to study this regression and see how good it is. So next, go to the next activity here. I'm going to clear the screen. Let's clear that. So let's go back to our presentation. So we did that. 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 I did not do this, but we basically have. So this was our residual plot from Excel, and here's our residual plot from R. And as I said, Excel is graphing this. Excel is graphing this as a function of the X variable. I can get this plot in R. It's just not the standard. It's not the first thing that comes up when I hit the default. You can get it. You just have to type more stuff in to get it. And then this is in R, it's being done according to the fitted values. And you can look at these two and you can see that they are all really almost the same plot, right? Because there's certain, so you can see the shape of this, right? I mean, this point here, and this point here, and this point here, and this point here, and these two little points down here, and these. So it is the same plot, essentially, basically, with, you know, it's just looks a little different in some of the alignment, but it is basically the same. So so it's not really so critical. It's more of a matter of personal taste and choice as to which one you think is the best to have right away. And then when I just talked about this, we have this in Excel as well. So this is the Excel normal probability plot. And there you can see they're pretty similar. The scale is different. This is the percentile scale, and this one is the quantile scale, and they're a little different in what they actually mean. And so it does, you can see already there's a shape difference. We get this funky long tail in the Excel plot, just like here. But in the Excel plot, we kind of missed this. That kind of just disappeared. It just went away. And so I would argue that the R quantile plot is superior to the normal probability plot, because the normal probability plot is kind of hiding. You can't see it. It's buried somewhere in here, this bump. So I would say the R plot is better in terms of showing us what's going on. Next, okay, now's the fun part. Now's the fun part, and we're good on time. We're doing just fine on time. Now's the fun part. So we've been doing just, you know, one regression. We've been doing just, you know, one variable. Right? We do that in Excel and okay, we get a result or whatever. But our data set, of course, has many variables. Our data set has, I don't know, what is it? 7, 8 variables? I can't remember. Has a lot. So we need to kind of start thinking about, well, how do we combine all these variables to get a correct solution? So it's basically the same math. And at this point in the course, we're done with manual calculation. I'm not going to, you can manually calculate all this, but we're not going to do it. So we're done with that. So it's essentially the same idea. It's not really different from the single variable, but we have all these questions like, which variables do we want to include? And what about outliers and transformation of data? Should we do that? That's another topic that actually does not get a lot of coverage in this book, but which is covered in a much more detail in my other book. And I will copy and paste some pictures from the other book to kind of give a little more detail to that, because it's actually quite important. But But let's take a look here. Let's try this. So this is from 2 weeks ago. So 2 weeks ago, before the exam, we had a chunk of time where we went on Excel and we plotted these 3 different variables separately. And so these are the residual plots from those 3 separate attempts. And here's the R-squares for those 3 separate attempts. And oh my goodness, the one in the middle is the one from the exam. How did that happen? So anyway, let's go and do this in a more sophisticated way. Let's plot them all together. Let's do this regression all together, right? So it's same formula, same command in R. But now if you want to do multiple, all you got to do is add them into the formula like this. So it's the same as before, but it's, you know, output variable, the Y variable, tilde key, and then how many variables do you want to put in? Put them in like this. And then the data source. And it will generate a multiple regression of this data. So let's do this now. And if you do that, you get this result down here. Actually, I've already got it on the screen. This is a reminder of what it is you just asked for. And then we've got some statistics on the residuals. And then here are the coefficients. And then here's got an R-squared. And some statistical significance of the regression. Now, think about this for a minute. So we have an R-squared of 0.69. Pretty good, 69.5, not bad, pretty good, right? And before, the best we could do was this 0.58 with the num lanes, right? So by combining more than one variable, we've punched up our R-squared. Now, this is not a stupid question. Maybe some of you thought about this is not a stupid question, but you might say to yourself, hey, I did this one, whoops, I don't want that. I did this one, num lanes, and then I did this one, county pop, and that's 0.58, and that's 0.38, so why isn't it 0.96 in the R-square? And that's not a stupid question, actually. Part of it is because, number one, these two, county pop and num lanes, they may be correlated. So it's not additive because one of them is already covering up part of the other one. So when you put both of them into the regression, it's not so simple as saying, well, I got this one and this one's going to add on top. It doesn't work that way. The two of them are correlated. They cover each other. They're correlated. So starting with num lanes and then adding county pop on top of that doesn't give you 1 + 1 = 2. It gives you 1 + 1 = 1.67, right? Like that, right? So that's what's going on. That's why you don't get this direct, just add them together kind of thing. And that makes it more complicated to figure out what goes where. So here's that result, and we can look at this table. And there are a couple interesting things here, one of which you may remember from the exam. So county population is definitely a significant contributor. But it's a significant contributor with a very small coefficient, right? 3.3 to the -2. So it is statistically significant, but it has a small impact, right? Statistically significant, but not a strong power. So this is, you know, and then we go down here to the width of the lanes, the bane brill, the physical measured width of the traffic lane. That's what that is. And again, not a big impact, 7.3 to the -1, but 2 to 20 times as large. No, yeah, 20 times as large as county pop, right? Because it's power of 10.1 and it's the coefficient is twice as much as county pop. So on paper, it looks like width lanes is 20 times more important than county pop. All that be careful. I shouldn't be saying that because these coefficients are also a function of the data, of the underlying data. So it's not, we can't compare them directly in that way. There is something called a standardized coefficient where we can compare them, but we'll get into that maybe later. But over here, p-value is a train wreck. P-value says, hey, you better take your money and go to Vegas instead, because this is not where you want to gamble. So horrible p-value. So the width lanes is not useful. And then we come back to num lanes and we come back to a better value here. We got a significant p-value and the coefficient is big, but num lanes is not a big number. Num lanes is like 2, 4, 6, 8. Who do we appreciate? No, but it's not a big number. So it has a large coefficient, 1.4 to the 10.4, because the number it's multiplying is really small. So again, it becomes a little tricky to compare these coefficients. So really the probability, the p-value is where it's at here, folks. The p-value is the game manager here. So, okay, so we did that. So now, get back to my controls. All right, so we did that. I've already talked about this. That's just my conversation. Oh, let's look at the confidence intervals. And here again, right? So width lanes has a confidence interval that includes 0. So not a really impressive coefficient right there. Yeah, don't like that. Everything else is pretty standard on here. Don't have much more to say on this screen. So this is, I wrote this slide actually a while back, but we did have this question on the exam. Well, yes, we did have this question on the exam actually. I had the first question on the exam on the midterm. What is the fitted regression equation? That was actually, a form of that was in fact on the exam. I did not have on the exam calculate the fitted values. I did not have that, and the residuals. That is something that could be on a future exam. I think the final exam, unlike the midterm, the final exam is going to be a situation where you really you'll get a data set, a large data set, and you really will actually have to do it in R. It will be something like, here's the data set, regress this thing, and tell me what the best model is according to this method, and show me the residual plot and comment on the residual plot. That will very definitely be a final exam question, very definitely. And then here's the answer for the fitted regression equation for this data. That you should be able to do now already. And of course, could have been done in Excel. Here it is. Here we are in R again. And then exporting. And I think I will spring over actually taking the time to do this on screen, but it's here for your reference. If you want to export some result from your R, you can. And here are the commands to do it. And You know, maybe, you know, R is such a pain to work with sometimes. Maybe you'd rather just export some results and then work with it further in Excel. And that's fine. So we got that. All right. So we can run this again without width lanes. We looked at that and we said, hey, width lanes is a joke. Let's not do that. So take it out of the model. So we run this again. So here's the result without width lanes. So we can see here that we really, this is a win-win, because remember what I said 2 weeks ago, all things considered, all other factors considered, if you can get almost the same result with a simpler model, choose the simpler model. So here, does this look familiar? The R square is just as good as it was before. It's just as good as it was before. And the p-value for the fitted regression is just as good as it was before. And we did it with just 2 variables. So this is what I'm talking about. There's no reason to include width lanes in the model. It doesn't add anything. And the model is just as good without it. So drop it, take it out. That's what I mean when I say the goal here is not to create a regression that has every single thing in it. The goal here is to find the most compact, the most Beredukti, maybe not Beredukti, but the most compact, the most sensible, the most efficient model that gets you a good result with as little complexity as possible. And that's really what we want to do here in our models. And that's where it becomes subjective. That's where people begin to disagree, because there will come a time when you have a model, and there were examples in the paper we read about delays on the Netherlands railways. There will come a time when you've got this model, it has a certain R square, has a certain significance, and it has, I don't know, 3 variables. And there'll be another model that has 4 variables, and the R square goes up by that much, and the significance is still good. And then you'll get into this argument about, should I stay with the 3 variable model or should I go with the 4 variable model? Which one's better? You know, and that can become a disagreement. It could be that 2 very intelligent, smart people could disagree on which one is the best choice. Now, it's not the end of the world when that happens, when you're in that debate, 3 versus 4. Very often the difference is very small, and it's like, okay, it's not going to be the end of the world. Don't worry about it. But it might be a big difference if we're talking about something really sensitive, such as AstraZeneca vaccine, right? Because that little bit of difference might be the 2 people that died in Denmark from the AstraZeneca vaccine, right? And the argument is, how do we know that they are affected by the vaccine or not? And we may not know, because we're getting to the data where we're talking about an R square and significance factors in the decimals, in the 0,00000 something. And now we're like, we actually don't know. I mean, we have a guess, we think, but it becomes difficult. It becomes difficult to say for sure, absolutely, this is the right answer. And that can lead to disagreements and fear and uncertainty, because sometimes that disagreement does have a big impact. The disagreement over that null, 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 null could be the difference between, yes, we go ahead and use AstraZeneca, no, we don't. And so it gets tricky. It gets tricky. And that's what keeps data people employed in jobs. As long as there's disagreement, that means there's a job for somebody to figure out the solution. So let's take a look here. So here's a survey. So here's what we kind of just looked at, what I just told you. So there was the 3 variable model and there was the 2 variable model. And so you can see here, we drop 1 variable, and the results are, in this case, in this table, can you see where the difference is? I can see where the difference is. It's really small. It's really small. There's a very tiny difference. Not a lot. Not a lot, but there is a difference. And I think anybody I present this to, any professionals would say, yeah, the 2 variable model is preferred, because you don't get anything. The 3 variable model is just more noise. It's just more hardware here. But so let's see, where are we on the schedule here? Just a few more minutes, and then we'll take another break. Just a little bit longer, and then we'll take a break. All right. So here we go. Quick review, folks. This is important. Hello, this is important. Listen up here. So let's remember this from 2 weeks ago. What is R squared? What is R squared? What is it? Here it is. It's right here on the screen. You're looking at it right now. R squared is all about the Y variables. R squared is all about the output. So R squared says you got a great model in terms of the output. That's what R squared is measuring. That's important. Remember that. What about the coefficients? What about the significance of the coefficients? Well, the coefficient significance has a little bit of the output in it. This mean square error has a little bit of the Y value data in it, a little bit, but it has a much larger bit. I'm running my mouse around on the wrong screen. Sorry. Oops. Let me try this one more time. This bit has the R squared, has the Y data in it, right? It has a little bit, but you can see that the X data is a much bigger part of this. It's much bigger part of this statistic. So the coefficient statistics are really driven by the X data. And the reason this is important, as we will see here in a bit, is it's possible for these 2 numbers to go in opposite directions, which maybe you didn't expect, but it can happen. So that makes it even more complicated in terms of us picking what is a good model. So let's see where we are here. Okay, a few more slides, and let's take a break. A few more slides, let's take a break. All right, clear this, mouse back. Here we go. So yeah, this is perfect. So let's a long break here and this exercise. So using the R and using the LM command, do the entire data set. So LM parenthesis AADT tilde everything plus on the right, and do that. Do that. I'll set up some breakout rooms, get some coffee, get a snack, and let's come back. Let's come back in 10 minutes again. Is that okay? Is that enough? 10 minutes again. Here's the timer. We're starting, and I'll set up some breakout rooms and try that. Breakout rooms, and there's, how many of us are there? There are 11. So let's do 3 breakout rooms. 1, 2, 3, go. go. All right, 10 minutes. See ya. right. Great. All right. So show me what you got. Who's got their solution or the answer or the analysis?
Vi har en, hvis det er. I can't remember what group we were, but
You
doesn't really
are.
matter.
Group 3.
No. Who was that speaking? That was.
It was me. Yeah,
Oh,
we were group 3.
Yeah, Milal is group 3. Yeah, Jonas, Lena, and Milal. Yeah.
Can you see my screen?
I sure can.
What can you see?
Okay, so you are using RStudio. Good for you.
Yes, yeah, we got the solutions down here.
Good for you.
Great.
But when you're using RStudio, is it actually making it easier? I mean, are you still having to type in as a command the linear model? Is there a graphical? Is there like a? Do you still have to type it in by hand, or are you able to do it? Or it just is all it's doing is saving your command lines for future use?
I'm not really sure.
I mean,
Yeah,
it
it
looks like your screen.
it saves it.
Yeah, so it's not like you actually have a menu where you just say linear
No.
model, go.
No, that's
still
too
have to
easy.
Still have to type in a model. All right.
Yeah, that's too easy.
That would be too easy. That would be too easy. You can actually do that in SAS. If we were using SAS, they do have a very nice graphical interface. But
Yeah.
I still want to look at that. The thing with SAS is I'm not clear. Well, number one, I kind of decided that we should, as a course, use R. It seems to be the trendy thing to do. And the other is SAS is a real pain in the butt. I don't think you guys have access to a license for SAS. That's the other problem. Installing SAS is not fun. It's a lot of work. Great. All right, here it comes again. Here we go. Still kind of a white screen right now. Flicker.
Yeah, just a moment. It's big. I don't know why it does that.
Flicker.
I can't really share screen right now, I think.
All right, never mind. Okay. All right, we'll just go to I'll just go show you my solution then.
Yeah, that's better.
Thank you for that. Let's just do it. All right, here we go. Yeah, and come on. Get my command of stuff here. Where are you? Yeah, there we go. Here we go. There we go. Move this. All right. And that's good. So here's my solution from the text-based interface. But so of course, so you get a higher R square, but a whole bunch of stuff is not significant. A whole bunch of stuff is not significant. And this kind of raises some questions. But this is why I made a point to refresh those definitions, right, about R squared and the individual variables. Here's an example where we have increased R square, but we've done it by adding a lot of stuff that in fact is not significant. And so the R squared alone is not a good judge for whether or not the model is correct. And here is the residual plot, and this matches what you were showing us, Milal. And here's I saw this in the far right, bottom right corner of your screen. It was buried under the dialogue, but it was there. I saw it, the residual plot. So here's our residual plot. And this has clearly got a nonlinear pattern in it. And so this clearly calls for some transformations. There's something that needs to be transformed here. And we would see this more clearly if I plotted the residuals against the individual X variables. And I have not done that yet. I have not done that, but it can be done, and it will be done later. But for now, this is just the quick result I've got here. And you can see clearly this pattern, this curve here. And so there's clearly evidence that we need something fixed here. And then here is the original residual from just one. Here's the model down. Where's my mouse gone? There it is. For just one variable num lanes to the full model with everything over here on the right. And clearly the residual pattern has improved. I mean, we don't have this blocky. Let me get my sketching tool here. You know, the original, from when we just had this variable, we've got this clear kind of cone going on here. This is definitely better, but we clearly have a band. We clearly have some kind of a band going on that really needs some kind of correction. And this can be done by transforming the data and doing some other things, because this can definitely be improved. And we will see how to do that a little later, next week probably. So then the question becomes, what is a good compromise model? And we can do this manually, and we can do this manually by just deleting some of the insignificant stuff one step at a time. So for example, here, if we delete this width lanes value, we get a result that is statistically better. And we can see here, we only lost a tiny bit, right? We just lost a little bit in the R square. And then at the same time, the truck route p-value got worse. So this increased. And so that also is going to happen as we start to remove things and move things around. There's a knock-on effect, and it now is affecting other data in the results. So we've now made this even more insignificant. And so now that would be the logical next candidate to take out, to check UL here. And so what I do is that is in the next picture. In fact, I do in fact do that. So the next picture, now I take out truck route. And now we actually, as I say down here, there is actually no change in the R square. So we took out truck route, and almost with no price, no expense, this actually was not a problem. And taking truck route out suddenly made this variable significant. And let's take a peek back here. Come on, oh, I gotta switch back to a mouse. There we go. So that was axis control, and axis control here is just on the borderline of significance. Really, see, axis control is 0.00, let's see, now let me run my head, 0.005. Actually, that's not too bad, 0.005. I was thinking 0.05. 0.005 is not bad, not too bad. 0.05, that's good. So it's 0.005, which was already significant, but now I go down here, I go here to the next level, and it's 0.0027. So my eyes, that was actually already significant at 0.005. I was thinking 0.05, but 0.005, it was significant, but now it's even more significant. It's gone up, it's increased in its significance. So next, let's talk about, okay, what am I going to do to make some of these judgments? Because we get lots of different choices here. And how do we transform some of this data? And one of the ways we can transform this data is in terms of qualitative variables, indicator variables. So a lot of the data in this set is not really a measure. I mean, it's not, you know, it's not like you can take a tape measure and just measure it. It's more qualitative. It's a classification. In some cases, it's binary. So we need to restructure the model. And again, don't forget, anytime you see red text in the slide, I'm quoting the page in the textbook where this conversation happens. So if you want to see where this presentation connects to your textbook, there's the page number and the section right there in the bottom of the screen. So we want to do here an example of a category transformation. And we have this variable in the data called functional class, which is given a numeric value, but those numeric values are not measures, right? They're just categories. So for example, we have this numerical value 4 that says urban non-interstate. Doesn't mean that category 4 is twice as useful as category 2. Doesn't work that way. And yet that's the data that we put in to the regression model. So clearly that's maybe not a good idea. Maybe that's not good. So we need to turn this data into something that the regression model can understand correctly and work with correctly. And so this is not 1, 2, 3, 4 is not the way it should be. What we want to do instead to get this into the model correctly is we need to create a series of binary flags that are simply yes, no, yes, no, yes, no, yes, no. We want to create a series of logical flags. And so we want to take these 4 values and we want to stretch them out into separate columns so that if this variable is true, then it means this is the category. If this variable is true, then it's this category. If this variable is true, and these are mutually exclusive, and if this variable is true, this is the category. And if none of them are true, then it defaults to this category. We need to actually redo our data. We actually need to transform our data. Now here is, I'm going to just demonstrate this, but maybe I'll not spend a lot of time doing it because it's not fun. But you could just take the Excel file and just do this in the Excel file and then re-import the Excel file. And that maybe in some ways is the quickest way to do it, right? Just create 3 new columns in the Excel file with these labels, FC1, FC2, FC3, and then just put in 1s and 0s according to which matches which category here. That's one way to do it. If you're curious, I did do it in R. It's a lot of work, but I did do it. So in R, I did a transformation in the R data frame. So and it's kind of because one little keystroke mistake and this is all wrong. So you got to go back and like fix it. But so I did a transformation here. So you can call what this is doing. I'll just explain it. I'm not going to demo it. It's a lot of work. What this is doing is this is the new data set that I'm going to use. And then I'm going to create a new data frame to go into that data set. And that data frame is going to contain these columns. And so to call the columns, you actually type the data set name, the $sign, and then the name of the column from that data set. And you repeat that. And that gets me all of the original columns. And then down here, I create a function and I say, if this is 1, put in a 1, otherwise put in a 0. And I do that. And I do that 3 times, and that gets me my 3 extra columns. And then I got to rename the columns because the new data set that I got created here does not automatically come with really pretty, attractive columns. So I need to redo that. So this command down here renames the columns, and it puts new names on the columns. And I'm going to cheat a little bit on my side and do this by just copying and pasting these commands from my presentation here, because I don't want to retype it all in again. So let's put that up on the screen. Let's put this over here. We got that. Okay, that's great. And I'm just going to manually copy and paste this because I'm not interested in. There you go. We got that. Copy, paste. Oops, I got to get my mouse back. There we go. Paste. Whew, that was a lot. And it looks correct. That is correct. And that did it. All right. And then change the names. I'm going to copy and paste this text from my presentation. And that's good. And now I have this new data set called transform. And there it is. Now I don't have all those empty columns because I manually, but there it is. And I think you might be able to also copy this command line from the PDF of the lecture slides if you want, and just do that on your R installation, or take a moment to recode the spreadsheet and put this in the spreadsheet. But anyway, there it is. So there's the data. And now, turn this back on. Now, there we go. And there's our new data frame. So now do that. Do that. Regress that one. And in just like 5-6 minutes, shouldn't take forever. Probably the most time-consuming thing is getting the data transformation. But let's just 5 minutes. It shouldn't take forever. It this shouldn't be, not even that maybe. In fact, when you're done, just come on back. Don't wait for me to call you. When you're done, when I see everybody's back, we'll just go. So let's do that. Just do it, and I'll keep an eye on this. And when you're back, I'm back. Preston and Tui, you're not working. What are you guys doing?
We are done. We have made it.
Oh, you're too fast. You're too fast.
Did it while you were talking about it.
Yeah, that's fine. That's great. I'm glad to hear that. I'm glad. I'd much rather hear you guys tell me that it's easy and you got it all done than hear you say to me, I can't figure it out. I can't do this. It's not working. It's always easier to work with students who say it's too easy. It goes too fast. I am nervous about the guys who don't show up.
We're sitting, Steven, we're sitting on a different channel together, and Kristen's helping us. So that's why we don't go into breakout rooms, because, yeah.
That's fine. I am nervous about the other, 13 students who are not here today. I worry about whether.
But how many didn't turn in the paper in the right format?
A few fixed it, and then I think I'm still waiting on
Because the first time you said the format was wrong and then people hadn't gotten theirs back, I thought, oh my God, I made a mistake then. And then I went in and checked and I'm like, but I did turn it into PDF. So I was like, oh, okay, that must be fine.
Yeah, I think
First I was a little nervous, like, what did I do wrong? Like,
6 or 7 have not corrected the format.
okay, that's percentage-wise fairly large.
Yeah, it is. Yes, 25%. It's yeah, it is. It's 25%. It's kind of annoying. I don't know. I feel like I'm a babysitter if I gotta, say it 2-3 times. But it is what it is.
Well, it's fairly easy. You just write on learn that if you don't turn it into the right format, you get 0%. Then people choose themselves.
Bo wants to go outside.
Where's Daniel?
Trombone.
Oh, yeah.
Spring is coming. Oh, everybody's back. Okay, looks like everybody's back. All right. I just had to let Bo go outside. Bo wanted to go out in the backyard. Bo's my dog. All right, everybody's back. All right, great. So this time, how about Rasmus and Jonas and Tobias? Let's see what you got.
Yeah.
All right, error expected. Oh, that's just earlier.
Oh yeah, no, yeah, I made a mistake. So from here.
So have you regressed it? Go ahead and regress it. Go ahead and do the linear regression. That's the data's correct. You got your data.
Yeah.
But this build a, linear regression. Who's got the linear regression?
Yeah, we don't have that yet.
Go ahead and do that.
Can you just plot it or?
The whole, do the linear model fitting. Fit the linear model.
Maybe someone else who have done it can do it instead of me.
Tua, you've got it, right? Okay, yeah, there we go. There we go. All right. So,
And there,
right?
transform
So in your opinion, is this better?
compared to the last one.
Yeah.
I don't know.
You don't know? Come on. Is it better?
Well, should I got it? It's close to the same. It's almost the same multiple R squared value.
So it's as I think I will show on the next slide, it's a little bit tricky to come to a judgment. I think on the next slide I'm going to say I don't like it, but you can see clearly that the R squared has gone up.
Yeah.
So the transformation of the data did definitely change the model's performance because the R squared has definitely gone up. But the next problem we have is that all of those binary variables we created, the FC1, FC2, FC3. 2 of them are way out there on the significance scale. I mean, not, 0.6 and 0.4, not a super exciting statistic. So now we get into this question of what have we just created and what's really going on here. However, it could be, and we see it right here, FC1. Well, FC1, it's not great, but it's much closer to significant. See, because FC1 has a 0.09 p-value. So what is this telling us? All of the data from this column that we transformed, all of it is not necessarily meaningful and significant, but a part of it is, right? So this is the funny part, that all of it is not significant, but part of it may be. And so we could take this a step further. I didn't do it in the presentation. I haven't done it in my own, but we could. And one of the ways to take this further would be to say, hey, wait a minute, let's create a whole new category here. And that new category could be FC1 as a data variable, and everything else lumped into a different category. And I guess one way of accomplishing that, now that I think of it, is simply to drop FC2 and 3. And actually, I can't remember what's on my next slide, what I'm recommending we do on the next slide, because I've run out of screen real estate here to see. I didn't make a print of my presentation either. So actually, I'm trying to remember what's on the next slide here. But try it. Let's do that. You do it. You do the work for a change. I don't want to do the work. That's exactly right. Do that. And let's run that and see what happens. All right, so let's see, where is the, so we have an R squared of 8.813. What is the significant, can you open the window up a little bit so we can see? The lower left corner is kind of too small to see everything. We need a bigger eye on the lower left corner. You know what I'm saying? I can't.
But it doesn't get bigger than this.
Oh, okay. Maybe just the divider bar, right now we don't need to look at the residual plot at the moment. If we were looking at it earlier, you had it on the screen earlier in a size we could see things. Yeah, that's great. Let's do that. So now, and then let's scroll up a little bit. So that's a 0.8134, which is nice. And let's look at the significance factors. Wow. Wow. All right, do you see what I see? Do you see it? I see it. Everybody,
all of them is very low. Oh,
So if it would be, so this is one of the limitations of this window, of this R window software. We have to like copy and paste this onto another screen in order to compare things side by side. Oh, but the result is still there if you scroll up, right? Can you scroll up? Let's just scroll up. Okay.
This is
perfect.
the result.
All right. Yeah, here we go. Don't move too much. Don't breathe. Don't breathe. It's right where we want to see it. All right. But look, so FC1, FC2, FC3, right? So now FC1, FC2, FC3, because what's happening is, because the information has been split out over these different variables, we are actually diluting the information, right? You take this little bit of salt and you put it in a big can full of water and you can't taste it. You take that little bit of salt and you put it in a glass of water and now you taste it. And that's what's going on here with the FC1, FC2, FC3. Here, we split it out over the 3 variables and the significance factors are like 0.09, 0.4, 0.6. It's diluted. You don't see it. Now scroll back down to this. Yeah, okay. Now we concentrate it. Now we just have the FC1 alone as a, we're basically saying in the whole data set, I want to compare things that are part of FC1 and things that are not part of FC1. And now I strengthen my data set, and look what happened to the p-value. The p-value is now crazy significant. It's 3.1 to the -8. That's crazy significant. That's super significant. So that one factor now makes for a very significant variable selection. And we have a nice R squared of 0.8134. And we've done it, if we look here, so I think what I'm demonstrating here and what we're going to learn is that before we jump into the next point here is, clearly this can just, there's a lot to do here, but it also can become very tiring because this whole process becomes pick, choose, test, pick, choose, test, transform, pick, choose, test. Could become a lot of work because you're constantly you just hunt, peck, look, see what I find. The results change. You try again. So it is time consuming, but the results can get better, and you can find really interesting results. But we've just scratched the surface here. Thank you so much. I'm going to go back into the presentation now and pick up where I left off. And there we go. And we got that. And I'm going there. And there's that screen. There we go. So here's where we were just talking. And I made a little comparison to the previous model and pasted some data in here. So not only do we have this, let me get my little drawing tool here. So not only, this is what we were examining closely just now, right there, but there's the knock-on effect. So we put this extra data in, and now it is knocking on to the other data and causing it to change. So what changed? Well, some of these other factors are still getting affected. You can see this p-value went up, this p-value went up, but not a lot to worry about. Nothing, I mean, it's trivial amounts. But this p-value is, oh, I'm sorry, I'm going the wrong direction. This p-value went, I'm drawing it the wrong way. Let me draw it back up again. I'm left to right. This p-value got better. This p-value got better. This p-value got better, reading right to left. This p-value got worse. This one is worse than before. And then this p-value is a lot worse right here. That one's a lot worse. And then we were discussing this here in the last little conversation. So a lot of things move around. You move one thing here, and there's just, it reshuffles all these other numbers over here. But overall, this last model that you did, Creston, where we just went to FC1, I like that. That was pretty good. And we could just sit here all day long and just keep trying different solutions. But it can be quite cumbersome, quite difficult. So let's try something, and we're doing great on time. We'll do one more thing, and then we will call it quits. But let's talk a little bit about how we can automate this process, and we can automate this process. So it get very quickly tiresome and difficult to just sit here and do this one at a time. So there are ways to do this a little faster. So how do we do that? Well, here we go. So we have some what are called model building strategies, as referred to in your text here on page 97. And the most common ones, there are more than one, but the most common ones are stepwise regression and best subsets regression, or this is, your textbook calls this best subsets, but a lot of other textbooks and the R software just call it all models. They just call it fit all or all models regression. So there's different language according to which author you're reading. But the first two, the stepwise has a logic. And a lot of this also is a function of computing power. And even when I was a student, this question of computing power was a little bit of a concern. I mean, I was in the generation when I was a student, I was just that first generation where we had computers and we could just, what's the chat? I got, oh, never mind. Even when I was a student, whoops, sorry, I didn't mean to do that. Come on. There we go. I was the very first, really the very first generation that had access to like large amounts of computing power to just do stuff on the computer. And at the time I was learning to do this, it was still a concern that, well, you know, we can't do some of this because we don't have the computing power to do it efficiently or economically. Whereas today, some of the things that I learned or were told to do are effectively obsolete. We just don't worry about it. So for example, stepwise regression. So the argument behind stepwise regression is primarily to save on computing power. So with stepwise regression, you pick some quality measure, usually the p-value. And in a forward stepwise regression, you start with nothing and you calculate all of the single regressions and calculate what the p-values would be for all of those single regressions, and then pick the one with the best, in this case, the smallest p-value, and put it in the model. And then you loop around again, and all of the variables that are not in the model, you run through each one of them and you recalculate which one of them, if they are brought into the model, would create the best two variable regression. And then you pick that one and put it in. And then you repeat that process until you get to the end of you get to a list of variables where none of them come into the model and generate a positive contribution to the significance. And then you stop. And then the other form of stepwise regression is the backward stepwise here. You go the other way around. You start with a full model with all of the variables. And then you look through the list. And this is kind of what we just did now with this previous example. You have the full model with everything. And then you look through the list, you say, that one's not very good. Let's take that one out. And you take it out. And then you rerun the model, generate new results. And then you look through the list again, you say, oh, that one's not very good. Let's take that one out. And it's out it goes. And then you keep doing this, and then you stop when all the remaining variables are significant. And then you can go a step further, and I learned how to do this in SAS, and I think the function's in here, but I didn't bother to look it up just yet. And you can go a step further with something called stepwise both directions regression. And in each step, it adds a variable, but then it also takes a variable out. So it's a dance back and forth, and it keeps doing this dance until it gets into a loop where it's always putting in and taking out the same variable. And then it stops and it says, we're done. We're not going to do that anymore. And then that's the traditional thing I was taught as the way to do it. And that is because that method requires less computer power. That method requires less memory, and it is less demanding on the computer. Now, if we were going to do a regression with, 10,000 data points, I think even today, the computing power is huge and we don't care and we would just do it. But 10 years ago, we might have still said, oh, we need to be careful about memory consumption and stuff like that, but not anymore. I mean, it's just crazy how much computing power we have on our basic home computers now. But anyway, since we have so much computing power, The next method here on the list is called best subsets. And that's a misleading name. I think the all fit all is the correct name, because what it really is you are, in fact, you fit everything. You literally make a table of all the possible combinations of variables and do all of the models and make a table of them. And then you just look through the table and say, which one do I want to pick? And with the computing power we have today, that is, I think, quickly becoming the default choice. It's a brute force approach. It's not very intelligent. It is not the most gentle way of doing it, but we have so much computing power, it's just easy to just do it. So I haven't actually prepared a slide because I didn't know if we would get to this point or not, but let's go ahead and try it and then we'll quit. So these are the commands. These are the commands for doing that. So I've got on the screen here the command for forward and the step for all possible. And let's do this. And I'm just going to pull up my screen. I'm going to pull up my screen here. And here's this model. There we go. And what we need to do, what I need to do, let me clear this. What do I want to do? Yeah. It's a bit of a pain in the butt to remember what's what here. Only negative about, here we go. There we go. Just need a little text reference over here. Got it. Okay, I'm all set. All right, got it. Okay, now I can start typing this in. So I'm going to type in, I'm going to call this new model. New model. Whoops, come on. I got to change keyboard. This is so, I can't remember anything. Here we go. And Danish keyboard, there we go. And linear model and ADT, and back to American keyboard. Yes, and tilde, and back to Danish keyboard. Yes, there you go. And CNTPOP plus num lanes plus width lanes plus access plus function plus track plus locate plus FC1 plus FC2 plus FC3. Data is no. Data is combo. There you go. Transform. There we go. There we go. Yay, success. All right, here we go. All right, now, now I want to fit. Let's try first the step forward. So OLS step forward P new model. Come on. Do I have a package I need to install? I bet that's what it is. That's what it is. Huh. I don't think there's a package. It's annoying. I must need a package for this. Okay, the package is called OLSRR. Let's see, here we go. Package, install pack. Come on. Oh, here it goes. All right. There it is. Right there. OLSRR. OLSRR. And woo, that set off a big, oh boy. I just started something. Ooh, baby. Wow. This is like poking a bee's nest. So what's happening is this package, this package apparently requires a whole bunch of other packages. So there's a dependency. And all of these lines are all the other packages that this package depends on. So my installing this one package just triggered like 20 different package installs. Oh, crazy. One of the negatives of open source software here. All right, are we done yet or not? Or is it still anytime now? It's basically like, oh, why don't you just go ahead and reinstall a whole new application on your computer? How are we going here? We got anything? Oh, it's still, it says successfully. Okay. Wow, it's still, I had no idea this would trigger so much. It's still going.
Yeah. No longer any little conversation there?
I'm teaching.
Okay.
You're on camera.
You're still on.
Yeah, I told you. Meet my son.
Do you realize?
Well, the cameras, I'm waiting for something to install. But as long as you don't say anything pornographic, we're okay.
Oh, delivery on the garage.
Yeah.
Deck material.
Yeah. Bo's in the backyard, I think.
Okay. I'll take a look at this.
So that's your celebrity son from Hotel.
Yeah, that's right. Hey, Stuart, you want to do your thing? Hey, pretend like you're getting a package. Yeah, here you go. He's doing it right now. So pretend like you're in Bell Hotel and like walk toward. Yeah. So, is this thing done yet or what? No, it's still going. I can't believe that. I'm sorry, guys. I should have prepped. I don't know. I bit off more than I could chew. I had no idea this would be like, but in for a dime, in for a dollar, you know. I really want to see this result now. I'm all pumped. I want to see what's going to happen. I know what, I mean, I've done this. I did it. I used to do this in SAS. I was trained to do this in SAS, but it should, it's taken forever. Come on. Wow. There's a lot of installation going on here. I had no idea there was so much. It's still going. Oh, now it's going to give me a warning. Thank you very much. I love this comment line down here. Byte compile and prepare package for lazy loading. Lazy loading? I don't want lazy loading. I want you to get your act done. Get your work done here. Anytime now. Well, I wonder if this is doing the, if you guys, are you guys installing this too? Oh my gosh. Come on. I think Netflix was really made for this, right? I mean, like when you're trying to do some work and you, oh, lazy loading failed for package. Oh. This is when you like you know, when I was doing my PhD, I very often would have two computers going at the same time. I have one computer going just to like run calculations. I have another computer going for like email and Netflix. And I just like sit there at the desk with two keyboards and everything and just run both at the same time. Or email, Netflix, calculations on the other computer, waiting for it to, oh, come on, anytime now. Golly, I can't believe how much stuff. Didn't like some of these packages. Installation of package had a non-zero exit status. All right, let's try this. I don't know. Let's see what happens. I don't know what's going to happen now. Let's see. Still doesn't like it. I don't know. I'll try one more thing, and then if I don't get this fixed, then we'll call it a day. And I will do my homework to do this correct next time. It might also really want me to restart R. LM. There we go. Let's try it one more time. Shouldn't take as long this time because it already installed a bunch of the others. I don't know, 4 o'clock. Give it another 10 minutes. If we don't have a result, we'll call it a day. What's the message? Messages. You think I need Penter as a package? Well, not according to the documentation I'm reading. Plus the error code I'm getting is not that the syntax is wrong. The error code I'm getting is it's not there. I think, but I'm doing this exactly from the documentation actually. But yeah, Penter is, what is Penter? Let's take a look. Maybe it's not in this documentation. No, it's not in this documentation that I posted on Learn. It's probably buried in some help file somewhere, extra commands. Yeah, I'll look it up later. Well, I bet this isn't going to work now. All right, I'll call it quits. I'll debug it and figure it out another time. Yeah, it's not installed. All right, I'll call it quits here and figure this out and then put it on the agenda for next week. So where are we? So that's what our agenda is for next week is for me to get this thing to work or find another package that does the same thing. I kind of already planned on next week being stepwise regression anyway. And so next week is stepwise regression and transformations. We'll look at transformations in more detail, look at some of that. And I will take a look at our schedule. I believe it's time for me to write another upgo. And I have a pretty good idea of something useful and fun to do. So I need to post that as well. So we have our next thing. And before I say anything more, no one corrected me. What have I just said that is silly? What did I just say? Little slip of the tongue. What did I just say? That is maybe not correct. What did I say? Are you already gone to sleep? I've already put you asleep. I don't need this anymore. I can close that. Yeah. Yeah. So Guposka. Guposka, and I do not see you next week. I do not see you next week. Guposka, and I see you in 2 weeks. So enjoy the holiday. Enjoy a little time off, a little break, and a little relaxation. And I'll see you in 2 weeks. So we are going to try. Yappy Easter. All right, everybody. So that's it. So this is good. I'm glad to see everybody in the group can get R to function, and you can get some results out of it. And that means that we can do some fun data sets when we come back from Easter. And we'll probably take a closer look at some of these transportation articles and the data sets in these transportation articles, which I have gotten at least one data set from an article author. So anyway, have a good time. We'll see ya. Kaposka. Be safe.